Cool, there we go.
The percentage one didn't work as expected.
Right. We might have to turn that around at some point.
Oh, so the thing is
And
percentage. I thought it was also percentage.
of course,
It's percentage.
somebody messed up.
We had 100% or we had less than 100% total.
Why do they do that?
With fraction, yeah, you can
So idiotic.
with pixels or font related.
It's gonna mess up all of my OBS stream. Right? Whichever instructor keeps futzing up this computer, stop it.
I think it's all of them.
Sir. So changing by the way I watch my server error happened. Not sure why. No, showing me. What's your with you were there?
I just saw this tablet up.
Okay, let's transfer what you use. So you have
Sort that out later.
So open up Task Manager.
Just not enough screens. Craziness. That delay drives me nuts. Right?
It's fun. I thought you liked computers.
I hate resetting the same machine back to working properly, only to have people whine and complain that the machine doesn't work right, and then leave it in a broken state, and often logged in, and then I have to come back and fix it again. So let's start this part off. Out of the way. See. So by this point, you figured out that this application is a little beyond the trivial scale, right?
A little.
A little? Okay. Okay. Is it messing with your brain a lot?
Yes.
Because there's a whole bunch of different things that I love about this application. And I don't want you hating on the application I love. The biggest thing that this application does for me is it forces us into this realm. Okay, when people learn to program, they concentrate on programming languages. They concentrate on where the semicolons and the curly brackets go. And that has about 1% to do with programming. Programming is about problem solving, breaking big, complex problems into smaller pieces that you can manage. And there's a whole bunch of tools and techniques that we need to apply to make those problems something we can handle and we can manage. And honestly, nothing of any serious scale gets done by an individual lone person. There's just nothing that's interesting enough to do that one person can do it alone. So anything we do in terms of the way we build applications that embodies a little bit of kind of the philosophy of the best way to do things, learned from all sorts of people who've done it before, that lets multiple people work on something nicely and cleanly together, is a good thing. So this is always a good place where I kind of stop and get into talking about how exactly are we going to try to architect our applications, because there's a few really high level things that if we keep in the back of our head will make our own lives a little easier, right? So we start talking about the kinds of things that architecture really means when we're talking about games and game development and software in general. Now, an architecture isn't about a piece of software. It isn't about an algorithm. It isn't about data necessarily. It's about being able to look at something and go, yeah, that's a game. That's a utility application. That's a command line tool. It's about looking at something and knowing exactly what it is by the way it's structured, the way it's built, and being able to look at it at code level and recognize that architecture with one specific purpose, and that is, can I go in there and change or fix it without breaking everything else around it? And the number one way that senior programmers get frustrated and upset is also the thing that drives junior programmers nuts. What senior programmers don't want you to do is to go into a piece of code that you don't understand and rewrite it because you don't understand it. Likely, it already works and has been optimized. So when junior guy jumps in and rewrites it, what they're saying is, I don't understand it and I didn't take the time to figure out what the architecture was behind it. Okay. So we want you guys to bypass that hurdle when you jump into working for game companies. We want you to be able to dive in day one and be productive. So we got to deal with this architecture thing. It's going to come up again and again and again. And it's not super complex, but it's not something that everybody thinks about every day. You get a problem, you sit down, you start coding, right? And that's usually the first sign that you don't really understand what you're doing. Once we get a reasonably complex problem, that starts to fall apart. And at some point, probably in this project, you've started to experience that. My head hurts, I have too many things going on all at once. I don't know how to segregate this out into manageable pieces. This is going on, that's happening asynchronously. The drag and drop doesn't work. I'm not getting the data I want. It sends me the wrong freaking error back. I don't get anything, right? We've all been there. So, we're going to start organizing things by taking a look at the whole problem and going, okay, how can we break this down into smaller problems? And each of those problems, we're going to try and reduce our complexity all the way down to the point of triviality if we can. If we can make something so easy that it's trivial, we'll do it. To do that, we may end up writing more code. And some of that code you'll look at and you'll go, wow, that was kind of wasteful. I wrote this much extra code and it didn't do any additional functionality. But what you're kidding yourself about is it does do extra functionality. So that functionality is the ability for someone else or yourself to come back to it in the future and extend it without breaking what's already there. Okay? And that's going to take some practice. That's that level of abstraction that you want, right? Now we see this all the time. I have a rough time with this because I'll talk with people who do some of the Unity programming in the game design stream. And we start talking in pre-production about how are you going to manage the data for your game? Well, I'll create a couple ints and a float. No. That's implementation. I need you to describe it in a way that if you were to hand it in a document to a programmer in Israel and never talk to them again, they would send you exactly what you're thinking in your head. Right? The implementation is irrelevant. It's really not that important. Code is disposable. We throw it away all the time. Abstracting the problem into small self-contained units, that's hugely relevant. That's exactly what we get hired to do. You handle hard problems by being able to abstract them down into smaller pieces you can deal with. And so we're going to dive into doing some of that. And all of the tools for doing that are guided by a bunch of decent principles that we all kind of adhere to that have been built up by a whole bunch of software developers who fed information back into typically the instructors in universities who encapsulated these things in written papers, and someone handed them a PhD for doing that as opposed to, just working on them. One of the guys that's crossed that boundary, I included this quote from him because he's done both. If you look up online Uncle Bob, you'll find a whole clean coding website. I have a link to it somewhere. You can take a look later. He's got a ton of stuff, and he encapsulates it really well. He's not the only guy to talk about this stuff. But a lot of the things that he encapsulates really well, I'm going to kind of paraphrase for because they're things that we all kind of try and strive for. So the first things should be pretty straightforward. Have you all heard these terms before? These are all acronyms. What's KISS?
Keep it simple, stupid.
Keep it simple, stupid. Okay? It's really easy in all programming languages to write really elegant, sophisticated code. Right? It's also really insanely hard to debug that. And it's even worse to try and fix it or modify it or enhance it later. So as much as it's enticing to do, don't is the simple word, right? The most common place I notice this is you get taught conditionals sooner or later. You know what I mean by a conditional, right? Where you're, something equals it's like an if then else, but all in one line. Really cryptic syntax. Yeah, don't do that. It's not that it won't work. It's not that it's technically wrong. But it's insane when you come back to it 6 months from now and go, oh, how exactly do these work again? And that extra time you have to figure it out, that's the problem. You heard these terms before. Keep your code dry, right? Not wet. You don't want to be wet, do you? You want to be dry, right? And we'll talk about solid principles.
What does it mean?
Wet?
Like dry.
Wet is write everything twice. Dry is don't repeat yourself. So, you have a chunk of code, it's only 4 or 5 lines, but you're using it twice. Again, I love picking on the game designers for this because you'll see them cut, copy, paste. Like as soon as I'm cut, copy, pasting, my brain has got red flags going off like crazy. Because as soon as I cut, copy, paste, I made that chunk of code, I probably have an error in it. As soon as I pasted it 4 times, I now have 4 errors in my code. Inevitably, I'm smart enough I'm going to stumble across them. And I'm going to go fix it in 1, maybe 2 of those places. And then the other 2 are going to fester because they're conditions that rarely happen, but they're still going to be there. And we want to write defect-free software. We got to avoid the cut, copy, paste errors. This is particularly painful with CSS and HTML because there's not real nice, easy ways to not cut, copy, paste stuff. Okay? There are ways. There are tools to do this, and we will do some of those tools, but they're all just kind of a means to avoiding that. What this means is carving things off into methods and functions so that we have small, reproducible, if we fix the bug in one spot, we fix it everywhere, right? It means when you're working in Unity, everything is a prefab because they're the equivalent. There are no lone individual objects. You don't cut, copy, paste 12 enemies into a scene. You make an enemy prefab and you put 12 of those in the scene. They're references or instances. You change the prefab once, they all change, right? Now I say this, but you will do it. Every team on the production floor that's been here for almost a year now still does it. They still don't completely get it. You have to be burned by it a few times before you get it. The solid stuff I'm going to come to because the solid stuff's a little bit more involved. So keep it simple, stupid, right? The simplest solution is always the best solution. Especially when we start talking about writing software, people get worried about what's more efficient, right? Programming-wise, optimization-wise, the amount of stuff you would have to do on this computer to make it inefficient is stupid large. And by stupid large, I mean when we start talking databases of 1,000 things, that's not large. When we talk large, we're talking about 10 million lines of code in the software and 100 million records. That's starting to get large. Until you get to that point, optimization doesn't matter. It's irrelevant. Okay. 10 million lines of code. How long does it take you to write 10 million lines of functional code?
And my biggest project is to write 2,000 lines. Just
Right. And the projects here I'm making you write are probably 4,000 or 5,000 lines, maybe. You get into some of the stuff we'll do next term, we're going to up the complexity a notch or two, and it'll get into the 10 to 20,000 lines of code range. So we'll be doing stuff together so that we're not, spending all day writing code for my class and not doing any of the other classes. Don't repeat yourself. I've explained, write everything twice. That's always bad. So the trigger here is as soon as you cut, copy, paste something, stop yourself. Take the thing that you pasted, turn it into a function, go back to the original, and call the function you just made. And functions, methods, same thing, right? The reason I use classes and methods in JavaScript is it's a nice way to keep modules together, encapsulate them. Okay. Which gets to solid principles. Solid, okay? It's an acronym. Single responsibility. Every module you create does one thing, and one thing only. Again, why we carve things off in classes. That class does one thing. The open-close principle. Anyone heard these before? Okay. A module should be open to be extended and closed to be modified. And what this means is when I build an object or a class, I want to be able to use it as a base class in the future without having to know how it's implemented. If I just have the API, just the public methods, that's all I need. I don't need anything else, and I can extend it and add to it. Okay. Closed for modification, same idea. I don't have to go into that module to change that module to be able to extend it. Now that's generally easier said than done. Okay. We have a nice part of JavaScript in that we can use inheritance. I can tell you that 90% of the time people use inheritance, they use it for the wrong reason. Okay. When we use inheritance, it's because something literally is an extension of something. And the idea here is if I build you an entity class that manages an object on the screen, a div, okay? You should be able to extend that entity and build a game object out of it, adding the functionality that you want without ever looking inside my entity to see how it works. You might have to call a few of my methods or overload or override a couple of my methods. But even when you overload them, what you're going to do is you're going to call my method first and then change things. You're not going to rewrite my thing from scratch. Okay, so that's that open-close principle. The next one is named after the guy who wrote this principle down, Liskov. And it kind of ties into that. It's trying to say that any program interface can't be confused with the implementation of another interface. And what we're going after here is the public API, the public methods on the class that you're using should be unique to that class, right? Now that doesn't mean the name has to be unique. It means that you shouldn't have to modify or augment that class to make it work. And the classic way that I see this is, I'll see things like, I'm going to build an editor class to manage the editor in my level editor. And the editor has an add component. And then I see another method that says add target component, and another method that says add collidable component. And as soon as I'm putting those object names in the methods, I'm violating this. Right? What I really want to do is have the component have an add method that takes the editor as a parameter. I want to flip it around. And then every component can have an add method. It's kind of consistent, right? It also means we want to minimize the interface or the APIs that we're using to any class. So we want to, particularly in languages that have a lot more private public kind of stuff, we want to make as many things private as possible. We want to only expose the things we absolutely have to expose. If we were to publish how you use that, you would publish the name of the class, the constructor's prototype, you know how you call it, and just the public API. That's all you should need. So we're going to abstract that away, right? And that ties into this, the interface segregation part, which is like separating things out so that nobody sees things they don't need. Now the last part of solidity is that dependency inversion. And going back to that example, the dependency inversion is exactly what I did there. I took the editor and the two different things I was trying to register with the editor, and I flipped them around so the things had the editor, not the editor had the things, which is sometimes a weird way to think about. The dependency inversion also tries to get through this idea that as much as possible when we make these hierarchies, we want them unidirectional. If I have a list of collidable objects, every collidable object should not have a reference to the level that contains the list. That's bidirectional, right? That means every time you update the list, you also have to update a thing as well. And you inevitably will forget to do that. So if we can make it unidirectional, great. Okay. So if something has a list of something else, those something else don't know about the thing that contains the list. You see this all the time with kind of management type objects or factories, which is a pattern that we might use. You create something that contains a collection of other things. The other things that are in the collection never, ever, ever, ever should know about the parent that contains a list of them. They need to be their own self-contained kind of little blobs. Right? So that's kind of the solid principle. So we take those principles and we want to apply them to our applications, right? I mean, nice, Scott, theory, beautiful, thank you, great. How the hell do I use that? Like, what use is that? So we start by talking about applying this to our current problem. And our current problem, the way I've structured it for you, it fits well with a typical event-driven application which uses an architecture we call model view controller. Model view controller is about separating out your problem into separate self-contained areas that minimize the amount of interaction with each other. I got a user here. A user does something. We have some part of our application that manages all the user interaction. That does not contain any data. Okay, and that's critical. That thing takes all its data and writes it out in a bunch of other components. So this is the container, those are the items, right? In here, we have any kind of business logic or application logic that we need to have. Now, fortunately for our level editor, there's nothing. It's just a bunch of data structures. At the same time, we have this view, okay? And in real world terms, in your web browser, what's the view? Do you write the view? The DOM, the document object, that's the view. You're not writing that document object. You can modify it. That's what the controller is going to do, right? The controller is going to write some data here. The controller gets some input. It goes and fetches some data, tells the view, hey, update this. The user's looking at that view, something changed. They give you some more input, some more action. Okay. That means we can also break down our applications using that kind of paradigm. Certain things are modeled, and quite often you'll see these as folders in an application. Have you ever seen an application that's got an MVC, three separate folders, or a model folder, a view folder, and a controller folder? That's what they're going after. And by doing that, I can make my applications a little bit easier. I can start to employ a technique called top-down design. Right? I go back to paper and I say, oh, what do we got to do? We got to make a level editor. And this architecture for this web, this model view controller, seems to work well for it. And it works for anything that's kind of event-driven, which is why all game engines employ this as well. And what we're going to do is we're going to say, look, I I don't completely understand all of the model data I have, but I don't really care. Okay? Because I can build some placeholders there that fake things out a little bit very quickly and just use those faked out things and kind of put them out of my head. I can rely on the browser showing things correctly. Really, all I'm writing is this. And when I write this, single responsibility, what do I have to manage, right? So this is where, when we're building apps where we're doing the user interface as well, we'll define the user interface, at least diagram it. We'll give names to different areas and components. We might even break that up into subcomponents. And with each of those subcomponents, we can turn around and kind of block them out without actually implementing them. So one of the tools we use to do this is a UML diagram. And I can tell you, 99% of the time, most people doing UML diagrams do nothing more than the name of a class. No properties, no methods. I'll figure that out later. I'll figure that out at implementation time. And when they figure out that UML model, they'll do it in separate pieces. On one page, we'll figure out our model, right? And this might be a little bit odd. I wonder if all this switching around. Nope. Okay. Jim's dead. All this switching around, we take a look at our game, and what have we got in our game? We got a level, right? And we got collidable things. And we got targets. And this level has a list of them and a list of them. Any number. Plus it also has a canon. Right?
That's the only one. Oh,
You should use different.
Hmm?
You should use different variables because.
I'm not talking about variables. I'm going to implement.
But it feels like there should be as many collidables as there are targets.
There could be. Oh, you mean you want me to do this?
Yes.
Does that make you feel better? You're not wrong. Just, you know. So by starting like this, okay, and the only reason I start like this is because I gave you the API and I gave you the data that's a spec you have to work to. And those are the entities in the spec. So this is my model. I can whip up a class for each of these. I don't know what the methods are. I'll probably build a constructor. I may not put any data in them to begin with. I'm going to stub them out. And inside, I might write a few comments on each one. I might put a comment about what each one of them is supposed to be. Right? I might do something really cute in there too. I might go, okay, now that I'm kind of looking at this, each of these guys has its own view, doesn't it? And they might have some properties, right? The bounciness, the
friction.
so that was all kind of in the spec. So I might pigeonhole that in there right away. The rest, I'm going to leave alone. The level, I'm going to leave alone. Okay. When I look at the controller, now I'm going to start breaking some stuff down. I'm going to go, okay, what do I have to do in the controller? And this is where we get into how do I abstract my problem, how do I break it down into smaller pieces. on the controller side of things, this is eventually what I want to construct. Now, working backwards, I know that if I want to construct it, at some point, I have to turn this into something I can send to a server. Right? Now, understanding that the server doesn't have to do any work in this case. The server is going to take what I send and save it in the file. Or I'm going to ask the server to retrieve something for me. It's going to give me a big chunk of something, and I got to turn it into this. So now in here, I'm thinking, okay, well, I got to do those two operations. So at first, I got to serialize. And secondly, I got to be able to populate. Right? I mean, normally you use a constructor for that, but in this case, because we're asynchronous, you kind of want to separate that out. Now, I chose those terms. You can choose whatever names you want. You don't have to use those terms. I choose those terms because in the next part, what I'm going to look for is some consistency. So before I ever get to code, I want to make sure, hey, I'm looking at this picture and I'm thinking, well, if that's got to serialize, wouldn't it be great if they all had the same API? If that had to serialize, if that had to serialize, if that had to populate, and that had to populate. And I don't need to know how to do those right now. I can just write a comment in serialize and go, well, this is going to turn this into a string. And I can write a comment in populate that says, well, this is going to take a string and fill in all the properties. Sounds straightforward, right? Okay. In your working life, this is quite often what you'll get. You'll get a spec. You might get the classes built for you, but likely not. You'll get a spec kind of like this with an API, and they'll go build. Go make this work. Okay? And you'll get kind of the comments on what you need to do in each thing. When we get talking about the controller part, it's the user of these things. So we can take a look at our application. We can start to think about what are we doing on the client, what are we doing on the server. We want to do a place where we're saving that model data somewhere. And we want that to be centralized so that if we have 10 different people editing levels, they're all talking to the same server, right? So we're saving all the levels in the same spot. And that's what drives us to this client-server part. Because the server is one central server, which means all that model data somehow gets saved on that server. Again, don't care about the details of what I'm saving just yet. I'm going to abstract that away into some sort of structure. Now, the further abstraction I'm going to have here is I'm going to get sent some data, and when I look at what do I need to do, I need to list all of the collidables. I need to list all of the levels. I never need to do any operations on the levels or on the collidables. All I need to do is be able to save or load them. So when I look at what the server has to do, that functionality, I don't have to manipulate the data, so I might as well just abstract it away and say, look, the server doesn't even need to look inside the data. There's no JSON parse. There's no deconstructing any JSON data on the server, right? Now, strictly speaking, we're going to have to do a little bit because we're going to get sent a message that we're going to have to decode. But one of the parts in the message is going to be a string. And that string might happen to be in JSON format, might not. We don't even look. All we're doing, functionality-wise, save the file, load the file, list the files. That's all we're doing. Okay. When we start talking about the client, now we're starting to talk about where does the functionality go. And just for completeness, clients usually come in two flavors, either fat clients or thin clients. And thin clients reasonably are things that have just the user interface part, just the view. Moodle is a thin client. Right? The HTML and the CSS show you everything. There's not a lot of JavaScript or interactability there, and all the JavaScript that is there is about sending all the information on the page to the Moodle server, where the Moodle server constructs a new page for you. It's always going to do that. All the work is done on the server. That's a thin client. The editor you're building here is a fat client. It has not just the view, but it also has controllers and possibly model objects in there. Right? So when we build these things, the number one question I have is, where do I want to store my data? Right? How do I want to use my data? So I can work from the back end. Understand the data, where am I going to store it? Now I know where I'm going to store it. Who's going to use it? Well, the client's going to use it. Okay, can the client use it the way it's stored? No. It's going to be stored as a big string. So, on the client, we have to have some code that takes that big string and turns it into that model. And that model we can now interrogate all we want. So as the user does something, the controller detects what it's doing and goes and interrogates the model or updates the model appropriately. When the user does something, pushes the save button, you tell the whole model to just serialize itself, and you send that to the server. That all starts from, first of all, know your problem. Okay, that's kind of common across all engineering, software, hardware, mechanical, electrical, whatever you're doing. It's just a part of the process. You got to know the problem really well. That often means you have to talk to people and ask questions, particularly when you start dealing with a game environment where you've got lots of different people trying to design how your game works. What are the features of the game? Right? Well, you're going to have this really cool character. He's going to move around in the world. Well, you as the programmer, in understanding the problem, are going to be like, okay, you said characters. We got characters. Moving around in the world. Do you think that's specific enough? No. So it's up to you to ask those questions. Well, I don't really understand what you mean by moving around in the world. Can I move forward and backwards? Yeah. When I turn, do I turn or do I strafe? Do I strafe or do I turn? Right? Now we're hoping our game designers know the answers to these questions, or at least the difference between them. But they're not always going to think ahead and go, oh, yeah, I need to identify that characters move forwards and backwards, and they turn, and they strafe, they jump, and they dash. And when they say they dash, that's typically all they'll tell you. They dash. Right? And when you get frustrated with it, you're just like, when you say they dash, I'm choosing what dash looks like. Unless you tell me otherwise. Right? And they'll start to get why they need to be specific. And this is all comes down to understand your problem. We also teach the UML to the game design students. You'll get to them before we do when you get to your team projects. Feel free to teach them the simple boxes. Okay? Draw that for me. Ask them to draw it for you. Watch them come up with 12 different boxes that are completely disconnected and have no relationship to other things. And you're like, well, how's that related to that? Right? And you're going to use that as a tool to help elicit an understanding of your problem from them. You need to understand that problem before you can start writing any software. Okay? We're giving you the tools for this. UML diagrams, so you're talking about what things, those become your models. Classes, that's how you're going to implement the UML diagram. The interactions between them, those are called use cases. And the use cases are going to help you figure out what kind of methods go on what classes. Right? As a level, I can save myself. There's a use case. And they're no more complicated than that. And as soon as I say, well, I can save myself, well, Do I know how I'm going to do the save just yet?
No.
No. But that's okay. I'm a software guy. I can wing it. So one of the things I like to do when I start getting to this part is make a list of terms. And this is just about me not getting confused with myself, right? You started to play around with this stuff in your level editor. Anyone got a prefab class or a prefab variable? How about a game object? How about an object? Which of course is a really bad name to use in any object-oriented language, right? Because that's going to cause some grief at some point when someone uses an object with the wrong capitalization and it creates a real object instead of the variable. Or you override the real object in JavaScript with something you named object, and now the whole world just stops functioning because you just blew it away. But when we start identifying how we're going to describe things, okay, when I look at my editor and I think about it in my brain about how I'm going to design this thing, I'm going to start to diagram it out so I understand the problem. Look at that, it's still here, but it's not the right way around. It's not the right way around, which really sucks. So we're just going to do it again. Now you know why I like my little whiteboards. So I go, okay, basic UI, I may or may not make it this way. Eventually I'll fill some stuff in there. Done, right? Here's the editor. That's what I'm actually working on. That's my level. Here's a library of prefabs. And this is just my fancy layout. Okay. Now David told me about your you know, hey, I put this in, Scott, and it didn't fill the whole page, right? And if you look at the units there, it kind of makes sense why. The grid I gave you didn't add up to 100% of the height of the page. That's all that was. So, because I mixed units in there so you could see that you could mix units. But you could make them all percentages and it'll automatically fill. You know, in that grid definition where I talk about a couple EM units here and a couple EM units here and a percentage here and a different unit here. You could just make it 5%, 5%, right? 60%. That's 20%, 10%. That adds up to 100, and now it's going to fill your screen all the time. So that's just kind of doing math. Okay, so understand the problem. I got to fill these things in. I've started to come up with names for things, okay? And I'm going to call what I put here maybe I'll call that name object. I don't know. Okay. In other words, it changes. When I drag it from here to there, I need to do something. I'm going to make a copy of it here. It's really just a div. I'm going to copy some of the properties from it, and I'm going to put them there. Some of the properties aren't view things. They're not part of the HTML, CSS that we're copying. Where do I get them from? I need a model, right? I have a library of prefabs. Game objects could extend prefabs. They could be the same as a prefab, just use a different variable name. But I've got to make a copy of these things. Well, I've got to make a copy of these things. Again, don't know how I'm going to do that copy just yet, but I got to make a copy of them. Right? You see how the APIs kind of start to emerge as you start to figure out how it's going to work. And again, I haven't got into the guts of any of these things. Okay. That particular notion, that idea of separating yourselves from the implementation details. Could I implement that in C#? Could I implement it in C++? So it's implementation independent. Can I implement it in Java? JavaScript? Swift? Kotlin? Yeah, because that has nothing to do with implementation details. Right? And that's critical. That's us understanding the problem before we start writing software. Now I've broken the problem down into a bunch of pieces. Now I can do the same thing with the UI. The trick with the editor here is that a lot of times the controller that manages this whole application gets really ugly. Because it's doing all the JavaScript, HTML, CSS stuff. But you can apply the same principles to break it down. Right? You can either have a level manager that manages the level, or a level view manager. They're all things, but as long as they have a single responsibility, it's all cool. So one of the things we'll show you today is how to manage the drag and drop stuff. And just as an idea, you can manage the drag and drop stuff by building a separate single responsibility component that attaches the drag and drop components or event handlers onto any component you want, any subcomponent you want, the subcomponent being part of the view, some element on the screen. Technically speaking, you could use the same thing to make the entire editor part draggable, because you just add it at a component level. It also means when you're thinking about it, designing it, okay, I have to make these things draggable. I don't know how I'm going to do draggable. Let's put the draggable thing to the side and just not do it. Okay. Which, if you're separating yourselves from the implementation details, is typically how we get bigger projects done. Because now I'm making kind of lists for myself of all the things I don't know how to do. The things I know how to do, well, that's easy. I can just fill in the blanks pretty quick. The things I don't know how to do, I might have to do some research. I might have to do some digging. But when I do that digging, I'm focused on one specific thing. Today we're going to do drag and drop. So I'm going to focus, I'm not worried about the model, I'm not worried about Ajax, I'm not worried about communication, I'm not worried about what I'm saving on the server. I'm going to drill down and focus on drag and drop. I'm going to build a component that makes my stuff drag and droppable. I haven't talked about saving the level yet. Right? That's a separate problem. But this is how we build bigger and bigger things, is we bust it apart into all these small little single responsibility components. And of course, if you get too many components for the amount of time you have, you bring all your friends in and you get 10 other programmers to help you. Like, you do this one, you do this one, you do this one, you do this one. We'll have a couple meetings about the API. I need to use your level object. Arsenie's building the level object. We're going to have a talk about the things I need to be able to do and the parameters I want to be able to pass. He's going to take those as the prototypes for the methods he's building. And he's also going to tell me to go away and not bug him about how it does it internally. It's not my problem to solve, right? I don't care. And this is how bigger pieces of software get built, because eventually you get to the point where it's not because you don't care, it's because you can't possibly keep it all in your head. So you don't try. So we do this by thinking and building everything in layers. And every layer that we build it like a cake. And we build those layers to provide some functionality to the layer above. So we're going to take our kind of model view, controller view, and we're going to slice it apart. So we've got our view, and then we've got our controller, And the controller is telling the view what to do, and it's getting input from the user, right? And it has a model. Layers. So, controller can add data to the model, add components, can interrogate the model and find information out, and it can update the view, that of course updates our user. Okay. So, as software, if I'm working on this guy, I want to ignore these guys. I don't want to hurt my brain with it. Okay? And I'm sure at some point in the last week or so, if you've started to do this part, you've had some module or file from this guy open at the same time as this guy, at the same time as this guy. And you start to get confused about who's doing what when. Part of the way we try and do that is it takes a little bit of discipline to break it apart. Start with the data structures. Okay. I usually start with the UI and the data structures and work to the middle. When we think about building things, I very often build things in what we call top-down fashion. A top-down fashion means, just like I was doing on the board there, I'm coming up with methods and they're stubbed out. So I'll write the name of the method. I'll have no parameters. I'll have no code. I might put a comment in there if it's not clear what this is supposed to do. Save probably doesn't need its own comment. Should be level.save. Wonder what that's going to do. You know, like I don't need to write a comment in there. Level.populate I might. Because level.populate, what am I assuming I'm going to get given? Well, I don't know yet. Let's see what's convenient. This part is the fancy way of saying be lazy. And I don't mean be lazy as in don't write stuff, don't build stuff. What I'm saying is defer any decisions about how things are implemented to the latest possible time. Okay. Implement as you go, and if you don't know how to do something, defer it. Write a comment in, defer it. Write some dummy data in. Do this all the time. I don't know how these objects are going to work. When I pull my little diagram around, I don't know how these guys are going to completely work. But I guarantee you I can make a collidable object with a constructor that has the properties that were in the data set, and I just hard code them to a certain number. Just put a value in. Every one of them is going to be identical. But now I can call a constructor and make them. And that doesn't help me with this guy, but it does help me with this guy, doesn't it? Right? So dummy data, stubbing things out, that's one of the fastest ways to build things, and defer those decisions till you know more. Right? At some point, it's going to become self-evident when you push the save button, the master big save button in your level editor. Something's going to have to go through and build that level. And it'd be kind of cool if save just took what as a parameter. Take the what. What are we going to do, right? So what save takes as a parameter, or what populate takes as a parameter, is up to you. Okay. Purists would say, you know, none of the view stuff, none of the jQuery stuff goes anywhere but in the view controller. So the editor class is the only thing that can touch jQuery. It means you got to extract stuff in the editor class. Your editor class gets big. You might have some subclasses. Right? Really, when we're building that level structure, what are we doing? We're going to use jQuery to walk through this element and make a list of all the sub-elements. And as you walk through every child sub-element, you're going to go grab some information out of it and use that information to build that data structure, to to the point where you can tell that data structure to save itself. So you can defer those things out. The last part, try and name things to avoid confusion for yourself. Right? And there's some subtle things to do with this, like never use plurals, never use like an S on the end of a variable name. That's just setting yourself up for disaster in the future. 10:30 at night, assignments due at midnight, it doesn't quite work yet. You've been spending 3 hours trying to wonder why entity and entities aren't the same. One just has an S on the end, right? Or collidable and collidables, really badly named things. If you had named it collidable list and collidable, it'd be really obvious. So picking intelligent names that follow your naming kind of structure and convention really help. And once you've got a basic picture of that and a couple diagrams, go back and ask yourself these questions. The way I've got this structure, the way I think I've planned on building this, is it dry? Is it solid? And if you think the answer's kind of yes, well, maybe you understand the problem enough. Now you can sit down in front of the editor and go, okay, let me do the easy stuff first. Now that's kind of the top-down also approach to application development, which 99 times out of 100 no one shows people because you're taking classes and lessons and showing you the details of how C# does private variables, which is irrelevant for this, right? That's problem solving. That's how do we engineer solutions. So when we look at our level editor, we can now start to break it apart into the individual challenging components. I can tell you where the challenging parts are. There's an Ajax part that's challenging. Where and who's going to do it, don't know yet, but at some point you're going to create an object. One of the properties of that object, according to the API, is called payload. And that payload is going to contain a string. That's what you're saving, that's what you're loading. So one of the parts is just getting the server and the client working so that you can pass that information back and forth. Another one of the problems is going to be a library of things, right? I mean, ideally you need some stuff to drag into the level. So breaking that problem apart into the library of things, you probably want to hard code a couple things. You can probably test the client and the server as well, because once you get the communication rolling, you could hard code in the server an object that you hand back and a list of library objects or prefabs that you hand back, depending on what you call them. Once that works, then self-contained, you can build something that goes and interrogates the file system for the list of files instead of hard coding it. Once you can do that, then you can go to something that loads one of those files on the server. And does it have to interrogate it? No. It just has to pass it back. It's a string. Load a string from a file. Cool, we can do that. Right? Server side's nearly complete at that point. Client side, okay, now we have to turn those strings into something. So you can build those things up one at a time. We're going to do this in the future with future applications as well, where we'll build some of the UI bits and we'll hard code the data in them. And then we'll build a model object and we'll build the controller that pulls the hard coded data from the model object into the UI. Right? Now I've proved that the UI works and the controller works. Now all I have to do is, where does that model object get its data from? Well, the model object could actually manage the interaction itself. It could make an AJAX request to a server. The server, I take the hard-coded data, I put it in the server. Right? Every time I'm just percolating that data all the way up to the UI. I'm testing those things over and over again. And finally, on the server side, I take that data and I put it in a file, or a database, or wherever it happens to live. And now, the only thing I'm worrying about is how do I get the data from the database or the data store or the file into the thing in the server that's going to percolate it up to the thing I've already tested a dozen times. So you take that hard-coded data from the UI and you percolate it down one step at a time, one layer at a time. So do you understand the editor problem now? The drag and drop thing is incidental. You can build the whole thing without any drag and drop. It's not as much fun.
Yeah, focus on the server and things more.
Yeah. Yeah. And that's just working from the bottom up. All right, let's take a break. And when we come back, we're going to review some of the stuff. I have this lesson set up to literally deal with a bunch of the questions, because year after year, most of the questions and challenges come up right about now. Right? Yeah. turn this on as we try and debug some of this. So, what's it complaining about? I got lots of errors here. Right? Can't find that, can't find that, can't find that, can't find that. So that's all cool. I don't care that I can't find that. So one of the things you guys should all do, and I didn't tell you about this is not something you would just know. Your browser tries to cache every file it downloads. So when you load from a server, it takes all of the JavaScript, CSS, HTML, it puts it in the cache. The next time you go to the same URL, it reads it from the cache, not from the server. That's how your browser gets a little bit faster. And typically the HTML and CSS doesn't change that much, so that's a real win, but we're trying to debug some JavaScript, so it really sucks if it isn't loading your JavaScript. So during development, it's also helpful to go to this network tab and just disable the cache completely. That cache is disabled if the debugger is up. If the debugger is closed, the cache is enabled again. Okay? So I'm going to do that. I'm going to reload this. And I can see now all of the time it takes to load this module. And my editor HTML is clearly the longest thing because I'm not loading any CSS. jQuery is pretty quick, 11 milliseconds. Right? And you can, it's got all sorts of cool stuff here it can tell you about. The waiting time you can't do about. TTFB means transfer time for first byte. So for the first byte, the first character to come through from the server, it took 18 milliseconds. And there's 0 you can do about that. Okay? Your job is to make sure that that's the longest thing. We're not even going to worry about performance. When I look at sources, I'm going to go to my index here. Not load. I did not load. Index.js. Sure. Couldn't load that. Because it doesn't load jQuery. So, let me just grab a couple things here. Okay, and then what else is it trying to load there? There we go. Oh, we'll just run that again. Right. All right. There we go. There's my index.js. All of this just to get to this point, right? I'm going to throw a breakpoint there. That line hasn't happened yet. I'm going to reload the browser. It's going to stop on that breakpoint. I'm going to create my prefab. So I've got my object. It's got my private data with all my attribute value pairs. Okay. The thing I'm going to send is this data to send. So when I serialize it, I need a line after that. Oh my gosh. Reload that. And what's the data descend look like? It's a string. It starts with a quote. What goes on inside the string? I don't care. Name in quotes, colon, value in quotes, comma, value in quotes, colon, right? Name, value, name, value, name, value, name, value. They're all strings. Right? So when you get that back, that's what it should look like. Not a list, not an array. Right? So what it's doing, because in JavaScript, when we look at, say, this guy, private, right, is what we call an intrinsic object. I just defined it with 2 curly brackets. All right. Behind the scenes, JavaScript treats these like what we technically call a dictionary as a data structure. And a dictionary is a special kind of array that's arbitrary in length, can be added to at any time, and is indexed by some certain value. That value doesn't have to be an integer. In JavaScript, those values are the property names treated as strings. Weird JavaScript thing. Let's just go take a look at, say, texture. So, some craziness, right? JavaScript objects are dictionaries. It's one of the weird and problematic and beautiful at the same time things. So when I look at temp prefab, I get the structure of it, right? Everything's all cool. When I step over value 3, ooh, why did that not give me what I was supposed to get?
Because you need to access private first, then connection?
No, because I already pulled it. That's supposed to give me the name property. Now I'm being too smart for my own good. Why does it not give me that? Oh. That should not be undefined either. What did I spell wrong?
So you have to go into the private variable first? How would you access the private?
Oh, you're right. You're right. I'm just being dumb. The part I'm not supposed to look at. You're not supposed to look at the private part, so I didn't. But thank you for pointing out that I was missing it. So those two are both ways of accessing the same things. This is considered much cleaner as you're working with objects, but there are occasions where this is really useful. Like for instance, if you get an object back like temp prefab and you want to fill those properties into a form, you know, you can use jQuery to get the data in the form into a variable. So I can grab a form and do serialized array and I get an array back. Not JSON, just an array. So it's up to me to turn that array into the proper JSON object. And one of the things you can do is use what you know about this to do it, right? So you could walk through let's say I did let me just clean that up a bit. I would never suggest you actually do this in any of your code. So if I do something like that, I can do really crazy things, right? Sign. So I'm going to go grab that and I'll just throw it in a variable called data. I can actually work with the right thing. So if I put that breakpoint inside, what's prop? Prop is an index into data.
Oh, it's getting all the name in the next one, then the next one, then.
Okay. So what if I changed it around? What if I was trying to load up a form? And what if I had an input, right? No space there. What would that do?
Grab a specific one and go.
So assuming, I haven't just picked a form here, right? So assuming instead of document, what if I did something smart and said, you know, so, and again, it's a little bit easier with jQuery, but so I'm going to go look through a form for all its inputs where the name matches the property name and set its value to the value in that object. But I'm using the objects as dictionaries so that I can put it in a for loop so that I can do it in arguably 2 lines of code. As opposed to having, 10 items that say query selector input name equals the new value. Query selector, right? Well, just because you didn't know. Okay? So knowing that you can treat objects like arrays or dictionaries as a data structure helps you decide, hey, there's some fancy ways to do this that might make my life easier. On the opposite side, when you use serialize array, okay, when you use serialize, well, let's just back up a second. And this little chunk of code is getting really, really messy here. Let's use jQuery to do this because I think it's fine. But if I'm going to use with my form changing appropriate names here. Really bad variable names. Neither of these returns you data that you can just pass off to the server without touching it. This one returns a PHP style parameter string. So it'll be like start with a question mark too. Okay, that's the string it'll return if you do the serialize. Okay. That's a PHP style query. If you do the serialize array, it'll create you a data structure, and that data structure will look kind of like this.
It'd be like an object, right?
It'll be an array of objects. And each object will have the name of the field, colon, and whatever the value is, separated by commas. Something like that. In both cases, you got to do stuff. This is worse, because you got to now deconstruct that string. That's bad. Doing things with strings sucks, right? The less you can do with strings, the better. This one's pretty easy. because I can take this whole thing that it sends back and I can walk the list. I don't know how many items are in the list. I can either get it by its length. I can do for of or for in. For of works really nice here because I'm going to get objects. For of gives me each of these one at a time. Right. So now all I have to do is match up in my data with the first item, right, in the object, and it'll be name, colon, and then the actual name of the property. And then the second one will be the value. So it'll have like name and then value, and name and value, and name and value, name and value. Probably didn't do that justice.
Is that not considered coupling the data? Because you have to make the objects the same name as the HTML objects, the attributes.
It'll be that. Is that considered what?
Coupling the data. You kind of connecting the objects and the HTML attribute names together.
Yes. Yes, it's a pain.
Is that a bad thing to do, or is that like?
It's the only way to do it.
Just to check it out.
Yeah.
Just check saving objects, just to see if it's in the right format.
Yeah.
Can you?
Is it checking? Is it saving it?
No, just check it's the right format that you think it's supposed to be.
So now it's pulling it back as an object. Does that make sense?
So now it's.
No. No.
Can I show you?
It's close.
Ah,
It's close.
Don't go away. You just put something else on top for I think it's not that much. So I'm doing the old way, like getting all the values
Yeah.
here.
So take object info.
Yeah, object info, yeah.
Okay.
And creating a new prefab, yeah.
No.
No,
Okay. After you create the prefab.
I created a
right?
prefab, yeah, here.
But
You
also create a variable there just before you create the prefab.
Okay, sure.
Don't care what you call it.
Okay.
Equals JSON dot stringify, capital JSON. Object info.
Oh man, what's
That's what you want.
that was this one I used for the creating.
Yeah, you can use object info for creating it.
Oh.
Well, no, you don't need to do that.
Okay.
Prefab is your thing.
Yeah, sure. And then
Okay.
for select
For the
and
request,
for
the payload is TTT.
Okay, so let's now okay. Let's see if I save this. Let's just save it.
Yeah.
Please save right.
Hi.
Yeah.
Okay, thank you,
So
sir.
when I'm writing here,
Ah.
saving it,
Yay.
then yes,
It's in the right spot. It's where you put it.
yes.
Sort of.
But I have to make it like go back a little bit.
Yeah, because
Yeah, I know.
you know where, right? Like your mouse is here,
And it goes like.
and
to
it's
top.
putting the corner
Yes.
there,
Yes.
so you can do the offset.
Yeah, I can do that. It doesn't matter.
Okay.
So I have a question. So this is the save button for
Yeah.
the level, and when I'm dragging here, data doesn't change anywhere. But when I'm saving the data, it reads it. Or when I'm putting it here, it automatically adds it.
When you're saving, say that again.
Well,
When you drag it,
when I
drop
drag,
it.
when
Yeah.
I drag it, it goes to the level.
Yes.
So kind of goes here, right?
Just saving this format, right?
Yes. Well, I mean,
Or when I
only if
save.
you do it. Only when you save.
Or when I save,
When you save.
it all reads.
Yeah. So you have to update this form yourself.
What
What
kind?
should be in already? But I
Maybe I don't
stay
have
into
enough.
the zero index always, right?
Yeah.
Zero.
Well, the X and Y should be enough, but the like the canon position. But like you could update projectiles, or you could like add a field for obstacle count.
Zero, one, two, and three should be just one.
Yeah, like we've got 2 obstacles in there right now, right? So,
Yeah.
So it's gonna.
But payload has an array, that array
So
has.
it can be edited
Yeah.
manually. It doesn't.
Yes.
Right.
Yeah.
Okay, so I have also obstacles and entities, and it's what
Yeah.
are entities?
it's in the JSON file. That's the other one. So here's the things that go in that form.
That's how the level save, but we don't have all the entities. We
No.
don't have all the entities.
So how do you get all the entities?
No, I mean I save on the entities. I save on the level, but I'm not displaying everything here.
Right. But you should.
I should display.
Yeah. Like all of this needs to be in the level object.
Can I see your level editor?
If I can make it run.
Why would all the data have to be in there though? Don't you already have the prefab data?
Right, but if you edit it.
So you want to allow editing
Yeah.
specific ones?
See, this isn't going to be the same because you don't even have those in the prefab.
Well, other than the X, Y, like
Yeah.
all the other data.
These things, you might not.
Because the way I was doing it was like the base data other than the X and Y,
Right.
whatever, was always going to be the prefab. So if you change the prefab, you change every single one.
You could build it that way, but that means that in the future you can't edit these on an object by object basis. You have to edit the prefab,
Yeah.
right? And the other part is, what does the API spec say? Right? If you want them all to be interoperable, everybody's got to save data the exact same way. Make sense? Like if you don't save this because it's in the prefab, and my code tries to load it, what's my code going to do? It's going to crash, right?
But what if on the server I just like connected it with the prefab?
Oh, that's fine. If you wanna open up JSON, decode it, add the right things with the prefabs, re-encode it, and then send it to the client, you go for it. That's totally cool. Or you could just embed it on the client and send a string.
Yeah, it's a lot of free data.
Yes. Yes. 90% of all programming is taking data from here, changing its formatting, squishing it together, moving it over there.
On the next break.
Yours. You want to see what mine looks like?
Yes. Because I don't remember it being so long. It had these.
We will lose some marks, but I can tell you a number. I don't know what it's doing then, but I know what number it is. I'm trying to remind myself these and a lot of stuff. Yeah, at the same time.
So you hired Jason now?
Yes.
So edit the
If you try to edit them, then
Kind
you
of.
edit every single one then.
Oh, you don't work?
That works?
No.
Because you're saving the level object and say the bounciness. It's based off of this prefab, but you change the
That's
level
it.
of that.
It's working.
And there's 20 levels.
Kind of not for
yeah.
yeah.
That object.
What?
And each of those levels have 20
This
levels.
problem again. Basically,
You got the drive.
What?
But you got the drive on the hard. Oh, you're doing gold.
Huh?
You're doing gold.
So when I add something here, I'm just adding a div.
Yes, I've also added it. So there you.
Yeah.
What? I don't know.
I update this automatically. That's generally one. And then max shots is something the user has to manually enter. I'm fetching this list from the server,
Yeah, it all works.
right? That's just stuff for the data, the user to add.
How do you delete the level?
Well, eventually I'll put it in my file menu.
So we're not deleting it
Don't care about deleting levels.
here. Okay.
I can always overwrite it. Right? And the same way I would choose a level and be able to, when I switch this, load the level and edit it, I would use File to create a new level, and I would use File menu to delete a level.
We have to use backgrounds.
You can
images.
use an image, like you can
Just
put
use
the
cover.
full .jpeg,
Yes.
right?
No, I know it's a background, and this
Yeah.
background says go to this image.
Yeah. I use a class
Okay.
because that way I can change it in the CSS.
And how do you? It doesn't have a drop-down list.
Nope.
Because
I'm not
because
querying the list. I'm just hard coding it.
how do you know what class do you have?
I built the server. Like I make the user type it in.
So he types it in, but
Yeah.
there's no CSS for this class.
Nope.
They don't want to change like the boundaries.
Well, no, there is for this guy.
For this guy, yes, but
Yeah.
you don't know if for the next.
No. Yeah.
you-
So I don't care. It's
So
a
you're
tool
not
for the
just-
dev, right? I can give him a paper list of here's the classes you can use.
Yeah. I think I was originally going to do it like that. Also, where
That's the keep it simple, right?
I think.
You could come up with a server query for this.
I think it's easier to make like a lot of classes already with some images.
Yeah.
And then just make a drop-down list.
Yes. And you can hard code the drop down list if you want to do that too. That would work just fine. That'd be a good idea. Shall we do that? You want to do a select there?
I think select would work because I would know what. I will
Okay.
not make a typo.
Let's see if I can do it.
If your classes are like image 1, image 2, image
Yep.
3, image 3, image 4.
Backgrounds. So for the background field, I'm going to make it a select instead. Always with the auto completion.
Okay, your name is working. It's just the same as I'm just using the here.
Happy?
And this one is also
That one's loaded from the server though.
yes, but if you want to make a new, you have to push this one
Yeah.
and
This would be a new. This particular button
Uh-huh.
would be a new prefab. I would just pop up a dialog to build it, kind of like
how
this.
do you create a new one?
File builder?
And it's not implemented.
And I don't have it implemented in this one now.
But what if I have this? It's like an input and a drop-down list.
Well, that works. That works too. Yeah. Yeah. Do fancy form stuff. Love it.
It's not fancy. I thought it's like easier to make a file.
It is. It is. You can make this an editable. So if you change the name, it just picks up whatever the name is and saves it. Yeah. That's great. Right. Yeah, don't change that. If you have it working, don't change that. Right? If I take level 1, paste it and make it should pick that up. Gonna work? Stop that.
What are you trying to do? The same?
No, it's not picking up my second level. Oh, I know why it's not picking up. Oh no, it shouldn't. Oh, that's why. I gotta fix that. You stealing my code again?
No, I want to make.
I gotta fix this thing.
I want to take a photo of your level. Of the fort.
Oh, you want to take a look at the...
Take this one.
Oh, Canon is not. You're not setting Canon. Canon is on the default place, right?
Yeah, again, I hard-coded the canon to begin with.
So it's always going to be in the same place.
You can put it always in the same place if you want.
Makes sense.
Yeah.
Why do you have many cannons?
Hmm?
How can you have many cannons? How can you have many cannons?
I don't think you can have many
But
cannons.
why it's been there?
Oh, I know why. I was doing that here. There's just one.
So why are we
Because you might want to move it or reposition it.
But cannons one says here, so it's like it's how many cannons? Like we only have one, why are we using
Just one. I've got at least 3 copies of this application on this computer.
That's confusing for sure.
Yeah, this is why we use source control and just have one. There we go. I was wondering why it wasn't working when I made a second level. Like I just created another file in the folder. And it was because I created the file in a different copy of the application, different folder.
Oh, the cannons is the exposition here.
Yeah, I have an XY position for the cannon, just kind of a locator for where I want to put it so I can move it. So I would pre-position it here.
Like each time you create a new level, it's.
I would just put the cannon in the default position and I would hard code it. And if you want to make it a draggable thing, then yes, go ahead and allow people to move it around.
I
Alright.
have a default, yes. Or I know it's needed, but I have a level.js
Hmm.
and the default values of level.
Yes, so it makes sense that all of the model things get their own script, their own class, you know, and that's that standard one object, one file, one class, and then single responsibility. In other words, it manages one thing. So the level object manages the level. Where you can get, well, you can either go too far, where you have a level object to manage the level data and a level manager controller, and that manages all the jQuery and the div and stuff. Or you could put them together, but now that level object is not managing just one thing. Okay.
Now I have just one problem. Kind of.
Just one.
Yeah, not really, but one that I need your help in.
All right.
So now, at least that part is working. I would load all my prefabs, that's like an image of them, but getting to this return before the for ends.
Correct.
So, yes, so how do I solve that?
That's what we're going to talk about now.
Okay.
Okay.
Okay, so I'm right being stuck here, so that's fine. Kind of.
Yes, it's so you're running into this exact issue. Okay. Okay. So let's talk about when things get complicated. Okay. We're doing this stuff asynchronously, right? So over here, I got a server. Okay. So you're probably going to need this, but it is a little bit sketchy. Okay. Not sketchy. It's a very elegant thing. Okay. But you can build this app without it. Okay. The trick to building this app without it is that your main application here the app controller or editor, whatever you called it, can send stuff to that server, and then when you get a response sometime in the future, control comes back to the callback function inside that post handler. Okay. Where you run into trouble is if this guy, let's say, decides that it's going to ask the server for something and then move on and do something else. And typically, when that happens, what it's really happening is your controller asks the model to do something, and the model asks the server to do something. Okay? Because when the server comes back, it's coming back to the model. And the model has no knowledge of that controller to know what thing on the screen to update. So you kind of want to percolate it up, right? You want to say, hey, when I get back, tell the controller I got back. Does your brain hurt? Because they're both asynchronous.
No.
Right? And the way you do it in JavaScript is a really slick mechanism that no other language can do. And it's called a promise object. Now the crazy part is you've already used them. Okay? jQuery uses promise objects. When you do a jQuery post or a jQuery get, the thing it returns you is an object. It returns you an object right away. You're supposed to hang on to it and do something with it. And if you were to define the interface to a promise object, it would look kind of like this. The constructor has two parameters. Actually, it has one parameter. A function. And that function has to have two parameters. It also has a then method that takes one parameter, and it has a catch method takes one parameter.
What's catch again?
Catches for errors.
Ah, okay, yeah.
Okay. So that promise object is what you're using when jQuery does a post on your behalf. It returns you one of these guys. And the object it returns, you chain together to call the then method. Now the then method doesn't get called until it returns, until it gets fulfilled, when a promise gets fulfilled. Well, it's kind of exactly what we want, right? So what we need to do is build our own promises here. And in the promise, we're going to do some code in this function. And the code we're going to do is going to post something to the server. So we're promising to come back to the UI controller after we get the server response. Okay? So when we start thinking about those promises and you start looking about some of the code behind it, jQuery does this thing all the time. I'm going to post. I've got these two parameters, that's jQuery's post thing, and it returns a promise object. That promise object, the return value from this guy, we're going to call its then method. And its then method takes a single function. We want to use the fat arrow functions here because I want to be able to reference the this reference that's inside this object, not whatever this happens to be pointing to at the period of time when it returns. Again, things are asynchronous. So the trick is, we're going to make our own. We still want to be event-based. We still want to say, hey, do this thing, and this thing involves talking remotely to a server. So we're going to do this asynchronous thing. And then, when you get an answer back from the second asynchronous thing, I want you to come back to me and tell me about it. Okay? It's like spending a rumor with a friend. And once we do this, we can do some really, really interesting, dynamic, interactive user interfaces. But they're a little complicated to debug. So you need to put the breakpoints inside these functions. So putting the breakpoint, it's like putting the breakpoint on the $.post is useless. Okay. So we're going to create our own promises. And you only need to use this if you have a part of your code that's managing the screen that calls another part of your code on the client, and that other part of your code on the client calls a server asynchronously. And the easiest way to think about it is think about a login. Okay? You pop the login dialog, you do that on the client. You collect the input, you do that on the client. You want to post that to the server, right? You don't want the application to go unresponsive, but you also don't want to show the user things they're not supposed to see until they're logged in. So, the dialog goes away. You're going to have to communicate to the server the login info. But what we're going to do is we're going to create a promise internally in the client, and that promise is going to create the query for the login info to the server. The server is going to do its thing and validate the user. When the server returns, it returns to the promise that you called. And that gives you the opportunity of saying, oh, I just heard back from the server. Now I can change the UI because that's a valid user. So it's percolating those promises up. Okay? It's a place where it's worth doing a timing diagram, because it can get a little messy. So if we come back to this guy, So the place where this is useful is if this guy does something asynchronous, like posting a message to the server. If I have my editor, I'll call it the editor controller because it's actually controlling the UI. And this has a level. That's the level we're trying to fill in. And all of the stuff in here is about updating the view. It's using jQuery. All my jQuery's here. This guy needs to talk to this guy, needs to talk to my server. So I can do a timing diagram for that. And that's where I start to go. An editor, a level, the server. Right? So the user pushes save. Now I want the user to continue to edit afterwards. So I'm going to new a level, create a new level. I'm going to tell the level to populate itself. And maybe I'm going to pass in an editor. Maybe I'm going to pass in a div or a DOM element or whatever. And then I'm going to tell this guy to save itself. And this one, I want an asynchronous response when you're done. This guy is going to do some processing on that level, and it's going to post a message to the server. And the server is going to do some work, right? And when it's done, it's going to respond. The response comes back to the level. Meanwhile, the editor's doing its own thing, and he's moved a dozen things around on the screen, which is cool. That's what we want. But we want to tell the user that, hey, the level got saved okay. So we have to get back to the editor somehow. So what we're going to do is just like the post method in jQuery returns a jQuery or a promise object, we're going to want to create our own promise object here. Your brain hurt?
Yeah, for sure.
Okay. You don't have to do this because all of the save and load things that we're doing, the save thing particularly is just going to acknowledge. It's going to say, yeah, okay, I did it,
Yeah.
which you can ignore. The load thing can kind of work because you don't really, you can let people drag things around all you want. As soon as the level loads, you can wipe the level and replace it with the thing you just loaded. Like, you're building an editor for your team. You're not building a commercial tool. Building a commercial tool, you're going to do this. Okay. If you're going to do that, and you want the load to, you know, tell the UI, oh, I just loaded this. Do you want me to put it on the screen for you? I don't know why you interrupt it, but you could. So what you want to do then is you want to start building your own promises. So we create a new promise. This is an intrinsic object built in JavaScript. It's not a jQuery thing, it's a JavaScript thing. It's always available. And it takes one parameter, which is a function, which happens to be a function that takes two parameters. And these two things are also functions. Okay? So I'm going to take my promise object. I promise to do some work in the future when you tell me it's okay. Inside here, in this one, I'm now posting some message to my remote server. Here's the data I'm sending. And when I get a response back, I'm going to turn it into something I can use. And then I'm going to call the function you gave me to tell you that your data is available. Right? if it's not available, if you have a mistake or an error, you catch an error, then you can also call the reject function, which means that the person using this call would end up being able to handle errors. Where does this promise go? In the level object. Okay. So the editor controller makes a call to the level, save yourself. What you do is you make the save function return a promise object. So now your own code can have save this level, then do something else, like update a dialog box on the screen. Okay? So you can use it for when you get a response back, if you don't want that level object to know anything about the UI, which is common. Okay. The idea is fairly new. I will point out that, I said it's in JavaScript. It's been there since 2017. The last C++ update, I think, was 2017. Most people are using the 2011 version of C++. JavaScript moves a little bit faster than that. Because they're objects, you can manipulate them like objects. They really only have two methods, then and catch. And so that keeps them fairly straightforward. There is some additional syntax that is like syntactic sugar to make it a little bit easier to read some of these promises. Especially, as you can imagine, I've only got two levels here. But what if I had an editor controller that had a bunch of other objects controlling different parts of the screen? Now I might want to have the editor controller manage like global modal dialogues. And so I would have the editor controller call some other controller to manage like the library of objects, which calls the prefab library to fetch all the prefabs and wants to know when they arrive so it can draw them on the screen and let the editor know. So you can go as many levels deep as you want here. All right, so these functions, and typically, just like in Express, the way we write the Express event handlers, the get and post handlers, to have a response and a result object in the function that we give it. Very common that they're called resolve and reject as parameters. And quite literally, the then method on a promise calls the resolve method that was provided. That's all it really is doing. All right. So, lots of text. Let's just put one together so you can see it. Okay. All right. Let's see what we can do here. So, over here, and get rid of all of this crap. So let's say inside this fetch level list, is it already in here? Here you go, this is perfect. So in the fetch level list, I do a bunch of things here. This is where I'm grabbing that pull down list. I'm doing it really quick up front. I go grab the element. Probably should be a const. And I set its contents to nothing. And I go make a request to the server that's asynchronous. If you want to debug these things, I highly recommend that you break it apart. So first off, got to fix that because the jQuery one's gone. For debugging purposes only, I break them apart like this. That assert is just so that I can put a breakpoint there. That's really what it's doing. And then with the level list, this one's got a full thing, and then I've got a little catch on the bottom. So I want to make this asynchronous, which means I want to wrap it in its own promise. Okay. This is what I mean. It's going to get a little weird. I want to create a new promise object. I'm going to use the standard resolve reject. Break it apart, and then I'm going to take all of this and put it inside. Okay. Now, when do I use the resolve and reject? Well, as much as I catch that error, what am I going to send back? Well, instead of returning result.payload, I would now resolve with result.payload. The resolve method here matches directly to the then method on the caller. So now I do this. Instead of returning that directly, let's get the name right so it actually works. Just break it all out. How confusing is that? Right. I'm going to call fetch level list. The very next line will be here. Okay. This then clause registers this fat arrow function to occur whenever resolve is called. Down here, this promise object needs to be returned to me. And this fetch level list returns this promise object, and the promise object has a then clause, and the then clause gets triggered when resolve gets called, when the resolve function, placeholder, right? Likewise, if I want to do a real error here, I would reject it there. That's messy, right? So the first thing I'm going to do to clean it up is recognize that if I actually follow the outline part of VS Code, it collapses up kind of nice. And all I'm doing is returning it. So more often than not, you'll see this. Return new promise. Throws me a promise object. The next part is a syntax fun. So in order to debug this, you need to put breakpoints here, here, and here, and here to check all the cases. Okay? Putting a breakpoint here does nothing, because this code, when it executes, is going to run this line, which is going to trigger the asynchronous call and immediately skip to the bottom and return your promise object. That's not going to help you. Okay, so let's get into the craziness. Does your brain really hurt now?
I was thinking, like, can you do this a lot easier with just async and await?
With what?
With async and await?
Well, that's exactly what I'm going to show you, yeah.
Oh, okay.
Right? So,
Thank God.
but this is what async and await are doing. So, you got to get the whole promise object thing first. Okay? The promise object syntax is ugly because of the nested then crap and the way it debugs. So the syntactic sugar is to use that async and await. Where does the async go?
Beginning of the function.
Which function?
Oh,
This is a function, 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 that's a function, which function?
Declaration. Yeah, the fetch level lists.
No.
Okay, it was a guess.
But it was a good guess. Right.
Oh, what's the question?
Hmm?
What's the question?
Where does the async and await go?
Come on, guys, just guess one.
Well, I thought it was right else, because don't you have to make that function asynchronous?
And so start it from the other end. Where are you going to wait?
What the calling that function from?
You're going to wait everywhere you're doing something asynchronous.
Yeah.
So you're going to wait here, because this is the asynchronous call, right? And by awaiting, that means instead of a then clause, it's going to return a result. So now you have to declare a variable. And so where you figure out to put the async is you put it on what function contains this await. So this function. If you spell it right. It also means that the semicolon goes here and you don't have a then. And you don't need this as a function. So you don't need that breakpoint. Right? So this crazy one just finishes right there. Now, what was the other thing we tested in there? We're trying to return the payload,
Yeah.
so we wouldn't actually would do that. What we would do is break it apart. So where does the catch go? I mean, you're right, you need to do another one of these here too, because it's returning a promise object. Where's the catch go? I'm actually not even going to do that. Not always really simpler until you run the debugger. The catch thing goes here. Missing a curly bracket. There we go. Yeah. I mean, it's a little better. Either way works. The then clauses, it's more obvious what's going on. It's also much easier to get nested then clauses that go way too far off the side of the page to follow. This code won't go past the post. You know how I said it goes from the post right to the end and then gets out? And later it comes back and does the then clause? The await makes it stay here, especially debugging it, until it returns. When it returns, it takes whatever it returned and stuffs it in that variable. And if it has an error, it catches it there. And then you can step through this sequentially. Okay? You don't have to use these. You don't need them for this assignment. You will need them in the next assignment, so whatever. Right? They make for a much more elegant user interface because you can continue to do stuff in the user interface while the server's grinding away. You will barely notice it when the server's running on the same machine as the client because they're super fast. But if I were to take the server and say, everybody connect to my machine server, it might be a little slower. And if I would put my machine in like the UK, it would be really slow. So we go through and do them. The async here goes with this await. And the async here lets me use an await up above. So instead of this then clause, I could use an await here. With the one caveat that you can never use an await inside a constructor because you can't have a constructor wait for things. So you can't use async and await in the constructor, which is why this has to be done with a then. And because it's done with a then, I don't need to put the async here necessarily, because I'm just returning a promise object, and the promise object's then method is getting called. Like there's nothing that I don't have an await. So you basically you pair up the await with an async call. And I always do the await first so that I just percolate up to the first function that's that await is inside. Right. If I were calling fetch level list from another part of my program, I could put async in front of it and use an await on the caller. Right. It's really cool when you debug it because the debugger just kind of follows it sequentially, so it's easier to follow. Did that answer your question for what you want to do?
No.
That's exactly what you want to do.
Yeah, it's just.
In your level, make your save, return a promise
But
object.
I have a problem with the load actually.
Okay, make your load return a promise object.
Okay. At least I can picture.
Yeah?
That should. So
Yeah.
it's a good idea. It's.
Right.
Oh, that's.
The await goes in front of the jQuery post. It goes in front of the asynchronous thing.
Mm-hmm.
Okay?
That's right. Okay.
Okay?
So the rest of the is not important. The rest on the right side.
Well, this is just for this API call.
Okay. So mine is mine.
Yours is yours. Okay. So when you're doing your level load, right?
Mm-hmm. Yeah.
The load method in your level
Mm-hmm.
would return a new promise, which is asynchronous, right? You set up your request object. You let a result equals await the post, your API call, which would be API/save, or load rather, right? Followed by the user ID, followed by your request object. And you'll have the catch in there. This reject percolates it up, so it means whoever calls this has to have a catch as well. Right? Because if that reject gets called, it has to go somewhere.
I'm gonna try starting it, and I'm already in browser.
And then this is the actual work after it comes back.
I have a question about the thing. So this line,
Yeah.
it will have a user ID and like the name, doesn't matter, and the payload mainly.
Yeah.
And in this payload, it will have all that,
Yeah. Well, where's the JSON object then?
all that form.
Yeah. Just turn the JSON objects into the object that you created.
Yes. So it has all this form, but
Yeah.
also it has all the objects. So
Correct.
form has all the form of this,
Right.
and also it has entities.
Right.
It's like a
And that's an array. Where entities is an object.
yes, and it has like
It has targets,
targets, yes,
and that's an array.
yes, and
I think it's called collidables.
the question is, so the form may get it for that one,
Yeah.
save it,
Yeah.
and how will we update?
So to get these guys, what you need to do is take your main editor area and walk through all the child divs and find out which ones are obstacles and which ones are targets. And for each one that's an obstacle, you create an object to put in this collide list. And for each one that's a target, you create an object to put inside that target list.
I don't know what the name of your game is, or that's or that library.
When I get
on the site.
when I push the save,
Yeah.
I'm getting all this information.
Yes.
So I'm just reading the form.
Right.
What if I make also a form for targeting collidables here, but I'm hiding?
That could work too. But you can walk through the entities quicker.
Quotation.
Like whenever I add something,
Yeah. You could do that too.
I automatically update
Yeah.
the client.
But you could also keep it in a data structure as well. You know, like whenever you add something here, you could also add it to the structure.
Yes, automatically update.
Right. So like if this were your level object, then every time you dragged and dropped something there, you draw a div on the screen and you add the right thing here. That's what we're doing.
I just keep it there, and then when I press save, I go and read everything.
Yeah, that's what I do.
Ah, okay. So when you drag something, nothing happens actually.
I just create a div.
Yes.
Yeah. And when I push save, then I go grab the form data exactly like you're doing.
Mhm.
I go grab all the kind of like extra stuff, and then I put these lists together dynamically. I literally.
So when you read the
Yeah.
when you read the divs, you get the div. You ask. So your object name is your ID of the div, right?
I add classes to the divs as I add them to the editor window, so I can later select them and count them and find out their XYs.
Because these divs, they don't store the data, except like X and Y's.
Right.
They don't have the maths, but you have to know the maths. So you check what kind of
thing it is.
what kind of object it is, and you go and see in the server what it has, right?
Yeah. I store it, but yeah, I cache it. Right. It's in the library. So I have a prefab library of prefabs. So I go walk the editor and as I get each div,
Mhm.
I go grab the class names that are in it,
Mhm.
and I use the class names as a search in the prefab library.
So what I want to do is,
So that's how that informs me the API on the prefab library, right? Oh, my prefab library needs a find function that I can pass in a class name, and it can give me back an object that I can copy the extra parameters out of. But you're absolutely right in the assumption that's not the only way to do it. You could just as easily keep a level object, and every time you drag and drop something in the level, you add something to the level object to keep track of it. And when you put this data together at the end, the only thing you have to do is update the XY, or you could do it on every move. You just update the actual level object. You could bake it into the class names, you could bake it into the ID. Because you're creating those divs, you could create unique IDs.
my names are unique because
Yeah.
they're in names.
Yeah, because you're creating those unique IDs for each div as you drop them.
Even if because I'm just overriding. I can create the same name, but I'm gonna override.
Yeah, I mean for the entities inside here, you create unique IDs for each of them, right? Because everyone has a name. And because you're storing them on a per item level, you know what I mean? Like when I go, like part of the reason the data is open it all up, right? So unique ID, right? Now I might prefix it, I might not, but so as I go through every child div, I look for a class obstacle. That's the way I did it. And every time I find class obstacle, I go grab its ID, right? So I'm gonna save that. I get the X and Y from there. I take this and I go look it up in my prefab library to find this. And I add that into an intrinsic object, and I add that to the entities list in the save data in the level. And when I've walked through every div in my editor area, then I'm done.
Walk through the name for each. In here, get its name.
Yeah. So now when you call local prefabs, do await. It's not local prefabs.
Yeah, do something like that, but
Await.
Just that little snippet, Arseny. I make my level have a collidables array, right? And inside there, I look at the edit windows, children, every child that has the class obstacle. And then I run through jQuery's each method with each one of them. And inside here, it's all collapsed up, but inside there, I go and create an intrinsic object with all the things that are in the format. And then, yeah, I have to look them up in a couple places, but that's fine.
Yeah, you can return a value or you can just.
So that's doing it dynamically. You can do it as you drag each thing. You can do it when you drop them, you add them to the list, and when you drag it, you update it. You could update them when you're finished. You know, when you push the save button, maybe the only thing you do is you walk through your collidable list and update the XYs.
You can't pass it till that is.
That would be straightforward.
And to do the dot then, yeah, just remove those. And instead of, you just want to like do it normally, like you get that data and then you just want to JSON that parse. Yeah, so you want to get the data.
So hopefully that's enough pieces to get you over some of the big hurdles, right? You don't have to do the promise thing. It's not really required, it's just nice to have, just to know it exists. You got another week to work on it, right? Because it's not due till next week. But next week I'll start talking about the game. So we'll build teams and we'll figure out what do we have to do. When you do the game, you reuse the server. Don't rewrite the server. Reuse the server. Use the editor to build the test levels, right? The only thing you have to do in the game, you're going to build a new application, but you're probably going to reuse your level loading thing, but you're going to have to augment it, right? Because you're going to have to add some physics stuff to it. So we're going to talk about how we add the physics stuff. And once you add the physics stuff and you've loaded a level, well, that's most of it, except for, you know, wrapping the game around it. You know, shooting a projectile is pretty straightforward. And it's a lot of fun. Once you get the physics working, it's a lot of fun watching things bounce off wildly and not go where they're expected. Okay?
It just